Hi class. In this video here, what I want to do is I want to work an application problem related to section 1.6 of your e-text. Now, these application problems generally are going to follow two types. There's going to be business and economics application problems, and then I'll throw in some social science application problems as well. So for this one here, this is going to be a business and economics application problem. So just some definitions. So we're going to define this function c of x. So the function c is a function of the x variable, and it's the cost of producing x items. So c of x is the cost function. Okay, then the average cost. Okay, so if you want to find an average, if you're going to produce x items, you would just take that cost function and divide by x. So that's the average cost function. Now, r of x is the revenue function. For the sale of x items, and then again, the average revenue from selling x items, you would divide by this revenue function by x. So, x would tell you if I sold 100 items, what would be the average revenue. And then p of x is the profit from the sale of x items. So this is the profit function. Now, what is profit, right? So profit is revenue minus cost. Okay, so I'm going to put this over here. Profit is equal to the revenue you get from the items you sell minus how much it costs you to sell them. Okay, so if you wanted to find the average profit of selling x items, it would just be your profit function divided by x, or your revenue function minus your cost function divided by x. Okay, so I want to do a silly example about a greenhouse that sells a certain type of flowers. So here's the problem, and we're going to come back to these average cost, average revenue, and average profit as we go through the problem. Okay, so Paulson's greenhouse find that the cost in dollars of growing X hundred geraniums, so that's a type of flower, is given by the following. So remember, X is going to be in hundreds. So you're going to input, say 2, but what that really means is 200. Okay, that's what I mean by X hundred geraniums. So this is the cost function. We're just making this up. It's 200 plus 100 times the fourth root of x. Okay. So, if you wanted to find the revenue of selling, I don't know, 1,000 hundred geraniums, okay? So it would be 200 plus 100 times the fourth root of x, okay? So just note, when you put in 1,000, okay, that would be really 1,000 100s. Okay, so you would tack on 2 zeros here, so it'd be 100,000 here. Okay, just so we're clear on that. Next, it says that the revenue of the sale of x hundred geraniums is given by this function. R of x is equal to 120 plus 90 times the square root of x. Okay, so these are just made up. Okay, this is the revenue function and the cost function are given there. So it goes on to say we want to find the following. We want to find the average cost, the average revenue, and the average profit when X geraniums are grown and sold. And then we want to find the rate at which average profit is changing when 300 geraniums are being grown. Okay, so just note that this is tricky. First off, whenever you see this 300 here, because it's X 100, it would be X is equal to 3, just so we're clear. Next, it says find the rate at which, so at the rate of change. So, rate of change here. So it's the rate of change of average profit. Well, what is the rate of change? Well, that's a slope. And in this class, what do we use to help find the slope of some function? That's the derivative. Okay, so that's where the calculus comes in here, because we want to find the rate at which the average profit is changing. Okay, so first off, we need to find average cost, average revenue, and that'll help get us to average profit. Okay, so we're going to denote these things. AC is the average cost, A sub R is the average revenue, and A sub P is the average profit. All right, well, average cost, you're just going to take the cost function, which was given, and just divide it by X. That's it for X geraniums. It's the same with average revenue, right? So you're just going to take the revenue function that was given and divide it by X. So the profit, the average profit function, you're going to take profit and divide it by x. Well, what's profit? Profit is revenue minus cost. So you're going to take the revenue function here, and you're going to subtract away the cost function. And notice how there's this negative here. So really what they're doing is they're distributing the negative for you already. Okay, so just so you see. But when you go through and clean this up, you know, like 120 minus 200 gets you minus 80. You have 90 times square root of x stays there. And then the negative here changes that positive. So it's minus 100 times the fourth root of x, all over x. All right, so this is our average profit function. Okay, when you're given X hundred geraniums that are being grown. Okay, so how much you're going to make on average per geranium that you sell. All right, so the next one said, let me just go back. The next one said, find the rate at which average profit is changing. Okay, so I need to find the derivative of this function right here. Okay, so first we must find the derivative of the profit function and then substitute 3 into it, and that'll tell us the average rate is changing. Okay, so what you're going to need here to do this, you're going to need the quotient rule, right? To find this derivative. So the first thing you're going to do, all right, and then there's a lot of algebra in this, unfortunately. It's the denominator times the derivative of the numerator, okay? So the derivative of the numerator, the derivative of 80 goes away because it's a constant. You're going to rewrite this as x to the 1/2. So you bring down the 1/2, and then 1/2 minus 1 gets you minus 1/2. Minus 100, you're going to rewrite the fourth root as x to the 1/4. So you're going to bring down the 1/4, and then x, 1/4 minus 1 gets you minus 3/4. Minus the derivative, or excuse me, the numerator times the derivative of the denominator. Well, the derivative of the denominator is real easy. That's just 1. Okay, the derivative of x is 1. Divided by the denominator squared. So unfortunately, what you have to do here is you have to clean all this up. So to clean this up, what you have to do is you have to distribute this to each of these terms, and then you're going to have to distribute the negative to every term. And then unfortunately from there, it's a little bit more algebra. So, right, so 90 times 1/2 gets me 45. X times x to the minus 1/2, well, that would be 1 plus minus 1/2 gets you 1/2. 1/4 of 100 is 25. And then x times x to the minus 3/4, you would add the exponents to get 1/4. And then look, distribute the negative, plus 80 minus 90 x to the 1/2, and then plus 100x to the 1/4. And then you can see here, you can combine like terms, right? Like this and this will combine, and this will combine. Okay, so when you do that, what do you get? So the 80 stays, right? You get minus 45x to the 1/2 because you have 45x squared minus 90 x to the 1/2, x to the 1/2. That's where that comes from. And then minus 25x to the 1/4 plus 100x to the 1/4 gets you 75x to the 1/4. And then this again is just the denominator squared. Okay, so that is the derivative of the profit function. So what this is telling us is this function tells us the rate of change of the average profit. So then what you're going to do if you want to find what is the rate of change of the average profit you're making when you have 300 geraniums, well, remember, you're just going to plug in 3. So literally you're just going to put in 3 for x. Then you'll grab a calculator for this to help you. And when you do, this is what you'll get. And so what this is saying is, thus at 300 geraniums, all right, this Paulson's greenhouse, their average profit is increasing because it's positive by $11.20 per plant. Okay, so that's what we're seeing here. So again, what you really just had to do to find these average functions, okay, is take the cost and revenue function, divide by x, Same thing with the profit. And then whenever we ask for rate of change, it's just a derivative. And then unfortunately, as you can see, this is a little bit of algebra for you to work through.